As we see trapped in daily gridlock, a double crisis is quietly paralyzing our transit networks. Good day everyone. Today our team introduces enhancing sustainable public transport through solar-assisted electric trackless tram technology. The ongoing 2026 West Asia energy crisis has driven global fuel costs to historic heights, severely inflating local operating budgets and leaving commuters financially strained. Our proposed 100% electric system acts as a shield against this volatility, establishing localized energy resilience along Klang's primary transit spine. To bypass this, our strategic route spans 21.0 kilometers with 16 stations, keeping station spacing strictly within a 1.5 kilometer guideline. Initiating at Klang Central Terminal A, we utilize high-priority dedicated lanes through dense residential zones, transitioning to partially dedicated lanes near Ahmad Perdana and mixed traffic with signal priority as we approach the industrial gateway. Crucially, this connects major interchanges at Klang Town Station 8 and Port Klang KTM Station 14, directly bridging the corridor's historic spatial disconnection. Our diagnostic audit of local feeder routes KLG1 and KLG4 reveals massive scheduling delays due to mixed lane traffic friction. To resolve this, our trackless tram introduces a high-frequency reliable service operating from 5:30 a.m. to 11:30 p.m. Trams will depart every 6 to 8 minutes during peak hours to efficiently serve port workers, daily commuters, and local residents. Operating at a safe design speed of 25 to 30 km per hour, this service slashes total travel times from end to end to just 35 to 38 minutes. In alignment with the Klang Local Plan 2025, our project targets a 25% reduction in corridor transit energy costs through solar-assisted opportunity charging, while cutting peak travel times by 30%. By bridging the spatial divide, we are securing a greener, smarter, and highly resilient economic future for Selangor Primary Logistic Corridor.
Our literature review focuses on the development of Trackless Rapid Transit or TRT as an innovative and sustainable public transportation system. According to Newman et al. 2019, many cities are adopting autonomous and electric transport technologies to address urban congestion, environmental pollution, and increasing dependence on private vehicles. The study highlighted examples such as Singapore, where autonomous shuttle buses at Nanyang Technological University improve first and last mile connectivity, and London, where self-driving shuttle trials have been conducted at Greenwich Peninsula. These initiatives demonstrate the global shift towards smarter and more sustainable urban mobility experience. This is further supported by the WSP 2026 report examining the emerging potential of trackless rapid transit, which highlights successful TRT implementations in China, particularly in Zhuhai, Yibin, and Shanghai. The report also discusses how countries such as Malaysia, Australia, and Hong Kong are exploring TRT because of its lower infrastructure costs and environmental sustainability and ability to support future urban development. Finally, the study by Chuan, Karim, and Yusuf 2014 found that commuters in the Klang Valley still prefer private vehicles due to their convenience and reliability. Existing public transport systems such as bus rapid transit and light rail transit each have limitations, including lower passenger comfort or higher construction costs. Therefore, based on the findings from these studies, TRT has strong potential to fill the existing transport gap by providing a cost-effective, sustainable, and high-capacity public transport solution while supporting transit-oriented development and urban regeneration.
Right now, I want to talk about the innovation and smart integration voiceover. Our project introduced autonomous rail rapid transit (ART) along the Klang Central to the Port Klang corridor. This system utilizes virtual tracking technology, mapping virtual lines via optical sensor (LIDAR) and a radar to completely eliminate the need for expensive physical steel tracks. Built on the 30.8 meter 3-module design, these trams carry over 300 passengers with a tight 50 meter turning radius. Secretly, the system interfaces with the MBDK Klang Intelligent Transport System using V21 communication to trigger transit signal priority at major intersection along Jalan Meru, effectively minimizing scheduling delays. Second point, I want to talk about the infrastructure reality and civil mitigation. Moving a 30.8 meter vehicle through Klang requires a hybrid lane approach to avoid gridlock. We propose a fully dedicated lane well route within the permits with a seamless transition to mix traffic in narrow, historic Klang zones. A critical engineering challenge is the prevalent routing phenomenon because the virtual tracking mechanism forces heavy tires to follow the exact same path with the millimeter precision. Standard asphalt face accelerate shear failure. To prevent road failure, our strategy implements full depth replacement using highly root resistant polymer modified asphalt combined with the semi-rigid continuous reinforced concrete slabs at a high stress station up. And last point is the operational resilience and economic shielding. This infrastructure is built to withstand modern challenges. The 2026 West Asia crisis has driven crude oil price beyond $100 per barrel, crippling diesel-reliant operators. By harvesting localized clean energy through roof-mounted solar panels and depot charging areas, our ART system significantly bypass reliance on the national grid and volatile fossil fuels. Because a substantial portion of our energy is direct solar capture, operating costs remain insulated from global oil spikes. This guarantees stable, affordable ticket fare for low-income port workers and daily commuters. Ultimately, this blueprint proves that our solar-assisted tackle Tram is not just future-proof technology, but a highly resilient solution tailored to unique economic landscape of Klang.
Hello everyone, I will present the financial implication for our proposed solar assist electric Trackless tram along the Klang Central to the Klang corridor. Compared with the convenient rail, the Trackless tram has a lower infrastructure cost because it does not require steel track or overhead power line. However, the project still requires a significant initial investment. The main costs include the purchasing Trackless tram, strengthening the road pavement, installing solar charging station, and developing intelligent transport system or ITS. Despite this upfront cost, the project offers long-term operation cost because it uses electric vehicle with a solar assist charging, reducing fuel consumption and maintaining expenses. It's also less affected by the fuel price increasing, make it more financial stability in the future. In the table right, show our the target include the port worker, daily commuter, local resident, student, and a business traveler. The group expect the benefit from the faster and safer, more reliable to public transport. Now I will explain the project benefit of the project. First, the economic benefits include a lower transport operation cost, reduced depend on the fuel price fluctuation, and a better support for the local business through improved accessibility. The second, the environmental benefit include a lower carbon emission, reduced air pollution, and less reliance for the fossil fuel by using electric tram powered by solar with assist charging. Finally, the social benefit include more reliable and comfort transport system, better access to workplace, school, hospital, and the commercial area, and all the overall improvement in the passenger travel experience. In a conclusion, although this project requires high initial investment, it provides long-term economic, environmental, and social benefits, make this all sustainability solution for improving public transport along the Klang Central to the Port Klang corridor.